Thanks, everyone. This is the first time I'm doing this one, and it's a bit not my usual style, so it will go very well, and then there's a risk that the wheels might come off, so please bear with me. But yeah, let me show you how your house used to look before we completely screwed it up. So first off, a bit about me. I've been doing a lot of stuff for a lot of years, but I want to kind of gauge, like, I want you to raise your hand if you've like deployed a website in, like, let's say 2016, and keep it up, and then drop it as I start going back, 2015, 2014, 2013, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2000, 99, 98, 97. Okay, so my point is I've played with this stuff for a long time. I've been around the block. I've tried a lot of different stuff. And for the last 2 years, I've really found like I found something really, really decent. Something simple, something nice, something stupidly productive, just something great. And that's kind of been my mission to now like share this joy and happiness. It's a bit different, so bear with me. But it's also something worth trying. And I must say, like, Luke and Kevin, like, thanks, you laid like such an insane amount of groundwork that I never even thought about. So let's get going. Who's heard of ClojureScript? Nice. Okay, that saves me a bunch. That means you've heard of Clojure. That also saves me a bunch. But so Clojure is a Lisp. This guy created it for us. Yeah, so if my hair could stand up, I would probably look like that, but that's not the point. So John McCarthy gave us Lisp. Lisp has been around for 60 years this year. No, 60 years last year. He gave us the if statement. That's quite like an interesting thing to think about. Lisp is not the oldest programming language, but we got the if statement from there. Before that, humans were the if statement. They looked at data and decided, like, we're going to run program A or we're going to run program B. Because if you think of like algebra, there is no if. And this guy kind of made it happen. So it's just one of those little things. But it's a gift that keeps on giving. 60 years later, we're still using this guy's work. And people love to make a lot of jokes about Lisp. I'm sure you've seen this.
Yep. Elegant weapons for civilized.
Yep. But what I want to show you is, even within the Clojure world, there's this ClojureScript, I think, is the most attractive part of Clojure. Backends are a heavy thing to go and replace and rewrite. A front end, conceptually less so. Probably more work, but if somebody wants to like apply a new framework or bring a new hammer to the problem, the front end is probably where they're going to start. So, and within the ClojureScript world, there's been a lot of activity the last few years. It's been crazy. People are really like figuring out what this means and how to make it easier for people to get on board. Because like the goats hinted towards us, like there's a mind shift. That's probably the biggest thing with switching into functional programming is never the syntax or the functions. Like, I hate to admit it, like that stuff's, it's simple. It's the mind shift that's the big thing to get across. And having nice tools that eliminates a bunch of other stuff and just get you going in quickly eases that mind shift. So I want to show off Shadow CLJs. This has been like quietly growing up in the ClojureScript world. It's like 4 years old already. The guy who built this had like a great focus on how can we get ClojureScript and NPM basically to work together seamlessly. Clojure, being a hosted language, prides itself on great practical interrupt. It's really, really important. It's not like some of these other transpiled languages where they go like the host language is over there. You know, you've got to do a bunch of effort to get to that side. And you've got to remain in this like very pure world that's like created in whichever way. It's super pragmatic. You're on the JVM, you need that JDBC driver, you use it right there, right now. You need that weird PDF library, use it right there, right now. And later you clean it up. Same on the JavaScript side. If you want to use jQuery, you just like reach out to $ and go. I mean, it's nice, it gets you going, it gets you moving forward. It's something I personally don't like about something like Elm, which puts up this huge barrier. You've got to use this port interface to do this dance. We're building stuff, man. We want to get stuff done. There's deadlines, it's tight. Like, we've got to deliver. That stuff's important. So This guy came at it from another angle, and it works really, really well. So what I want to show you, which turned out to be non-trivial, which I'm quite happy about, is unrolling a tweet storm. I'm sure everybody's kind of familiar with what a tweet storm looks like. I also want to use as much of NPM as is possible. And in this case, it's really impractical. But I want to show like how this different language is still a good player in the ecosystem that it plays in. It's not trying to be something, it plays ball, essentially. And as part of our exercise, we're going to produce a single JavaScript artifact that you can just take out and use anywhere with Node. So I said it turned out to be non-trivial. When you get a tweet, you can't actually ask Twitter, like, what's all the replies to this? They can do it, because clearly they show you this, but you've got to do your own black magic. So luckily, a tweet storm by definition only comes from the author. So then you would go back to their timeline, find all their tweets, then start like matching up based on the reply to, and then as you find each matching one, you've got to kind of like change the one you're using as a reference and walk the way down. So it turned out to be quite a list comprehension-ish problem, and an async problem, and promises are involved. So it's quite nice. So that's kind of like the idea for solving this problem. But first I need to show you some Clojure before we get into some code. So I was quite happy with a lot of hands that went up. So we can fly through these. But prefix notation, functions first. So the operators first, the operands come after. A lot of them can be variadic, things would, but simple examples. With math, it's especially nice because you never ever need to worry again about like operator precedence, because your brackets define the precedence, and you can just put your math together. I work with financial systems and a lot of data. That is a blessing, like not having to worry about that stuff. Same with giving stuff names and being able to use them. So it's not a variable, but it's a named value.
In Enclosure, we call them symbols.
Yeah, so in that case, X is actually, and the star is a symbol.
It just happens to be bound to the function.
Yeah. You can create an anonymous function, assign it to a symbol, and then you can use the symbol. I wouldn't write code if you had to do it that way, so there's some shorthand to help us out. Works exactly like the one before. This is what a map looks like, so very much like a plain JavaScript object. Keys, values can be nested. You can go in and read your stuff. That's how a shorthand for getting a value out.
Those things with colons in front of them are called keywords.
Same with vectors or arrays. Quite simple to just pop a value out. These are indexed very, very fast and simple to use. First taste of some interrupt, because you'll be seeing snippets like this scattered everywhere. But basically, we're going like, there's a .log function that we want to apply to the JS. So JS/ is our number one breaking into the JavaScript world. That's our interrupt. So, and the console is our friend console.log. So that's how we would call it, and we pass any arguments through. And the same for the window object or anything else in JavaScript world. It's right there, available to you at the moment you need it, which is quite nice. So this is kind of important because everybody's always like, the brackets. There's so many brackets. Who saw a comma or a semicolon or any other special reserved word or anything in that? There's nothing. Just because it's a different syntax doesn't make it more syntax. It makes it very, very little syntax. I'm a Rubyist by heart. I did a decade of Ruby, and Ruby suddenly has a lot of syntax to me. It's bizarre. This thing has very, very little syntax. It's functions and data. That's all it is. And from that simplicity, those building blocks, comes something spectacular. But it comes at the cost of a bit of a paradigm shift. So back to our problem. We need to get a tweet. We need to find the timeline. We need to start sifting through this mess to reconstruct. So Sarah May is probably the queen of practical tweet storms. I think she abandoned a blog for this. So this is the exact kind of chain we're going to unpack in this case. So now, something I'm not used to doing is like just walking through code. So but before I dive in here, any questions at this stage of the match, or like something that might need some context or clarification, or do you just want to dive in and see it happen? Okay, so what we've got is,
Make the background white.
I
Is that an easy thing to change?
I don't know. I couldn't zoom in Emacs for some reason, so I just installed Atom quickly and got going. But this is also good because people go like that. You should never learn Emacs and Clojure at the same time, so this is Atom and it works. Oh, you mean in Emacs? Something's broken with Emacs Mac. We're not going there. I tried earlier. It's a disaster. I'll show afterwards. Like it's really a disaster. We're not going there. So, but the nice thing is you're not bound to Emacs. So that's also like if you have different tools to use, there's different tools. This is Atom, yeah.
Whereas I will make the background white. So you guys
Check the better file. And then there should be another file.
Which one? There we go. Is that better?
Yeah.
Thanks, Lynn.
Just a general tip, if you ever present it, you want like as high contrast as possible. And white is much better than black. Just for people to be able to read from a distance.
More like yellow.
Or like yellow. The green fonts on the yellow background.
Nope. Okay, help me out. How do I open my project pane on the left-hand side here? Oh, there we go. So our directory layout is fairly simple. The camera is freaking out. It's memory card full. Please hold, we've got technical difficulties. And it's not mine.
Advert break.
Quick question.
Yeah?
The JS interop that you showed earlier where you called .log with JS console as an argument, why did they go for that rather than JS/console.log is the function and then you give arguments?
Yeah, you can do it the other way around. You can just go JS/console.log, but that actually ends up reading weirder.
It's actually a macro.
Is it?
Yeah, that rewrites.
It's funky.
Okay.
Yeah,
So,
sorry, in terms of that question where you saw that syntax where you went the method first and then the object name, it's very interesting if you go to the history of that because it took Bertrand Meyer like a hell of a long time to figure out you could go object dot function. Because you always used to call the function first. Because I want to do this thing with this object. Today your compiler rewrites that second parameter or inserts that second parameter as this implicitly. If you're in Java or C# or wherever, this comes in JavaScript environment. In another language, that was like it's a huge thing. It took years for them to go, hey, we can go object dot. So we like to put the functions first.
yeah, so I'm not going to bother zooming in on the left-hand side, but the project tree is fairly simple. We've got a source directory with a bunch of ClojureScript files, which we'll dive in a bit. And we need to configure shadow CLJS. You kind of need to hint at like where in the directory your files are lying. You want some dependencies. So these are not necessarily dependencies these are, in the Clojure side, dev dependencies or runtime dependencies. It doesn't matter. The compiler will sort out what you're using and what you're not using. So in this case, this is all development stuff, and none of this will ship. What is quite nice with this is it uses the package.json for your normal NPM packages. You just yarn add whatever you want. It's in Node modules, and you start using it. No weird dance. As long as it's available somewhere in the class path, the code will be found and can be used. And that is fantastically simple in this case. With some of the other ClojureScript build tools, it's a bit more of a dance. They want you to be more explicit about what you depend on so they can end up producing better artifacts and a better experience for you. It's way more plumbing. I like this approach because even Shadow CLJS itself you install with NPM. You do need Java somewhere on the system, but you never touch it. It's like running for you, and most machines have Java on it. It's just one of those things. It's a new Flash. So, and then you specify a few builds. It's just you want to target a Node script, and this is important because you can target like a Node library if you want to make it an NPM module, or you can target the browser if you just want normal ES5, and you would just tell it what to do and some other dev tools. This is not particularly interesting. What I do want to point out is we have some entry point into our system, which is our main function, and that's kind of where I want to start the little exploration. So, very, very short and sweet. I'd like really don't want to dwell on the details because it gets more interesting somewhere else. But this is basically our main function that will get called. It accepts a variable number of arguments. That's the special syntax. Don't worry about it too much. But the idea is we want to give it a URL to a tweet, and it will just go and like do its magic. But as far as like entering as a CLI point, that's all we want this thing to do is basically get the tweet ID and call something else. So if you want to reuse the same code in like a Express handler, you would do the same thing. Like you'll just like pass however you get the tweet out of your Express environment, and you would want to call the same thing and have some magic happen. And then we dive in and we unroll our tweet. So that is in our call function.
That threading macro, you see that arrow there? It's very similar to that compose thing you guys were talking about.
Yeah, or the pipe. So actually, I've got a slightly better example of that. That's why I don't want to highlight it, but it's quite nice. And then I will also allude to why I earlier said that I think the JS pipe syntax is a bit lacking. So if we go back to what I said earlier, the way we express our problem almost by wishful thinking is we want to be able to say, like, we want to get the tweet. That's our starting point. We want to get the author's timeline. We want to assemble a thread from that timeline. In this case, we have this funny need to expand the tweets because when you read the timeline, all the tweets are truncated, which is quite pointless. We want to have the full thing, so we want to be able to just expand them all, and then we want to print them all out. So what this threading operator does here is very much like the pipeline. This is the normal, I think this is what the ES pipeline is coming through exactly. So we start off with this function. Whatever its value is becomes the first argument to this function. Whatever it returns becomes the first argument to the next one. Whatever it returns, the first argument to the next one, and so it goes. There's also, and this is my thing with the ES syntax, is if you look right above here, we have a slightly different threading operator. This one pushes everything to the end. So now that's a thread last operator. And the way Clojure kind of deals with it, well, the standard is when you've got a bunch of functions operating over collections, the collections always go at the end. So map with the function, and the collection goes basically there. That's what happens. But the threading operator rewrites our code. And then we want to interpose some value into a collection. And we want to join with that as joining our string, and we'll have a collection there again. And then ultimately, it pops up at the end for console. So we've got two ways of threading, thread first and thread last. And there's 5 more ways, depending on what you want. It's a massive toolbox. There's conditional thread first, conditional thread last. There's an as threader, which can handle like any kind of weird mutation you've got if you want to string some stuff together that doesn't work, and a few others. It's a fantastically practical toolbox, and that's why like Elixir simple pipe first, and the ES thing I'm like a bit this is really nice. This is like okay. Anyway, so sprinkles of interrupt, and this is kind of what I hinted at. Like sometimes it gets a bit iffy. This is an entire promise chain, and then eventually we need to call then. Like at the end of the chain to do something. And I did this because I didn't want this function to be promise away. It was just as simple as that. And I wanted to kind of show that this stuff's possible. It's not how I think I would write this myself, but that's okay. So let's go and unpack it a bit. So the get tweet basically just calls a function in a different namespace. Namespaces in Clojure is a way to like organize your code. And the way to think about it is you organize the code by the problem space, not necessarily the solution space. So especially in OO, if you think like Rails, Grails, or any one other of these frameworks, Ember, Angular, whatever, like you've got your controllers over there. Like it's the solution to one problem goes here. Models is a solution to another problem. All your solutions get bound together. Your views live in one place. Something in Clojure that really shines, and it took me a while to figure this out, and I was saying to just a random mailing list article that I read, is like structure your code around the problem space and package everything together that's about the problem. And that is it's an interesting twist on just like your folder structures and where you put stuff, but it is fantastically powerful and a nice way to reason about things. And then if you ever get like the microservices thing like going and you now need to like split everything out into gazillion things, you just start taking whole namespaces and you just deploy them separately without ever touching the rest of your code. So it's very flexible. So what does our little API look? Here's an example of some interrupt. So in a Clojure namespace, we need to kind of require our external dependencies that we need for that code to run. And that all happens as part of the namespace definition. More specifically, it happens in this require block. So here's a few things going on. The first is that Twitter is the NPM package. That's in my package.json, actually. I keep saying this, but there's the Twitter gem. NPM package, whoops. You see like, phew. But this basically yanks in Twitter. It exports one function, and I want to get a handle on it. This goog.object, this is the Google Clojure library. Like the naming is quite crap. I don't know who to blame. But there's like the ones with an S, the ones with a J, the ones language, the other one's a super powerful library that you very seldomly use, but that gives you a great bunch of stuff. And this is just some other utils, and that's basically I made a little function that does promise.resolved with the value. But I just wanted something nicer, and I just want to go like, as promised, here's your value. So we want to read some config out of the environment, and this is your normal like node.process, process.env.value. I just tore it up a bit, and I just went like, I want to get off JS process, the env key. I've got that, and now I can just basically go and read my other values off. And this ends up looking something like, if that works. Doesn't seem like it wants to work in this weird REPL. But we should have seen a map, or maybe it worked somewhere else, doesn't matter. A little function to build a new Twitter client when we need it. Well, we'll get it going. It works in the background. I'll show you. I mean, I'm not in my normal comfort zone with tooling or presentation style. But here's the Twitter function we called, but this Twitter function expects a JavaScript object. That's what it's going to read the properties from. We've got a Clojure map full of keywords. It does not understand what this is. And if you were to get a debugger in there, you will see something that will make your heart stop. It'll be like clojure.core.persistent something with this like insane tree structure of values. But it's not for your consumption. It's like a machine concern. So we just need to tell Clojure, like, please just convert that CLJ value into a JavaScript value. And it just spits out a normal vanilla JavaScript data structure. And you're off to the races. Normal JavaScript function with normal JavaScript arguments. And we've got a Twitter client that we can start using. And then our status function essentially becomes, listen here, we want a client. We need to build up a URL based on the tweet ID. We want to make some extra parameters. This took a bit to figure out. And then I want to say, like, I want to do a GET request. I need to give it my client that it's going to do the request with. I want to give it the path, and I want to give it the params. And then here we've got another piece of interrupt again. So the Twitter client gives us, let me show you, map this over to what's actually in the documentation. Do I need to zoom in more? Oh, there we go. Whoa. That's good. Okay. So that's basically what you saw happen in build client, is exactly this little loop. That CLJ to JS on the map basically gave us out this JSON object. and we catch the return value, and we can use it. And then the rest of the API is essentially calling get, post, or stream with whatever the Twitter path is, the params, and a callback. Or if you drop the callback, it turns into promises. When promises are available, we Node, it's all happy. So that's kind of what's going on here when I go, I want to call the get function on the client. So this is interrupt. That's already like a sign that we're interrupting with something else. With a path, and again, we've got these arguments that need to become a JavaScript object. And they just go in. That returns a promise. The promise is threaded to with the thread first operated to over here. So it would essentially be the same as promise like that. What we've got here is an anonymous function that catches the response, and it just returns a promise, and it passes out. It turns out the JavaScript object into something nice for us with keywords in our map. So earlier when I showed the map, the A, B, and C all had colons. They weren't string keys. This kind of solves that for us, but it's a minor detail. So we can get a tweet. Then I'm not going to show you the implementation of this because I think it's going to derail us, but I made this little macro. So a macro enclosure, although it's something that the community pushes against using because macros are like a black art and they're difficult to debug and they don't usually play well. I think for the first time, like in 2 years, I found a good use case for this. And it's where I just basically, imagine you've got a function, it gets an argument, it tests if the argument's thenable. If it's not thenable, it basically calls itself again with a resolve promise. Else, the function goes on assuming that it's inside the then. So you've got this nice thing where you can work in the REPL and you can play with functions. You can just call them as you need them. And when you put them in a promise chain, they keep on working exactly the same way as before. And I found this was quite a nice way to just make this custom thing called def then. So Clojure macros are functions that return new code that then get executed. And this was the first time it worked for me, but I don't want to, it just makes for this nice semantic that we can do this. And if my REPL was working properly, I'll try it in Emacs and actually. Can you see that? Oh, no, never mind. So, so basically we can call this function with a tweet. We'll start extracting some values out of it. It's now just a plain map, so we can get some values out. This is quite nice when you've got a nested data structure. So we've got somewhere in this tweet is a user key or a user property if you think of the JavaScript object. Now that user property is an object all unto itself with all its properties. And so this basically gives us like tweet.user.user_ID string or ID string, and we've got that. And then we can basically go, okay, we need a new promise because we need all the tweets since that one. So we just go to the API. I'm not going to, that function's quite simple. It does exactly like the user status. It just builds up its parameters slightly different. And then, so we get this promise out. Then we just wait for the promise to be resolved. And its value is our timeline of the user. And then basically what I'm doing there is I'm taking our original tweet, I'm putting it inside a vector, so it's the only element in the vector, and I'm just jamming the rest of the tweets in there. So we've got this array where the head of the array is our starting point. It's a simple semantic, we've got it, so later we can always just go like, we start at the front of the list and we simply run through the list and get the values out. It's not particularly difficult. And now we're going to get to something interesting, which is nice. So we've now been through, okay, so we get the tweet, and we get the tweet timeline. So at this stage, the promise that gets resolved is this one long array with our starting tweet and all the rest on as one simple thing. Now to assemble it, this turned out quite nice. So same thing, we pick our first one off because we kind of need it. Like it's our starting point. It's our ID. We need to start finding what we got replied to. We need the user ID in this context as well. Now we want to make a short list of tweets. So now we went to fetch the person's entire timeline. Even though they're busy with this tweet storm, they might be replying in between to other people's interesting comments. So it gets a bit like crazy. So what we want to do for a short list is we just want to go like, look, firstly sort them by created at, because we actually have no guarantee that Twitter's just going to give it to us at time. And we're actually in this, like, I mean, I'm assuming a human typed out these things, so there's gaps between, but we've got no guarantee otherwise that these things can't come in at exactly the same point in time. So you might want to sort it by the ID as well. And you've got no ID, like no guarantees that Twitter actually gives IDs out in order. They've got a super complicated distributed system just for giving out IDs. It's a bit of a mess. Distributed systems are hard, but we just want to go like sort by created at, and we only want the ones that reply to the original user. So now we can at least get the list down to something, and then we can start assembling our tweets. So let's just unpack these quickly because they're quite short. Sort by created at is literally sort by with a property and then how to sort. So it will, like, what's quite nice here, and this is kind of hints to the functions as first-class citizens, that's key to functional programming, is that is the function. It's not a special symbol that means yay or nay. You can go put any other function in there. When the created at value comes off each individual tweet, it will be like the values of 2 ones will be passed to that function, and it either returns true or false, or the whole like 1, 0, -1, and you get your sorting semantics over anything. It's really powerful, and it's quite nice. But that's the function itself, not some special keyword, not something reserved, or like, it's a function. And here I wrote out 2 examples of, and here's like our first example of composing functions in Clojure. But let's look at this one. Filter does exactly that. You give it a predicate function and a collection. Every time the predicate returns true, the value survives. It will like come out on the other side. If it doesn't, it's false. And it's, as in this case, we've got a user ID, and the user ID is getting checked inside. That's our equality check. So that's our equality check. That's not an assignment operator. No like double equals or triple equals or something. It's like, is this thing, yes or no? It's quite nice. And in reply to user ID, so it's a property on the tweet. So we can basically go like, if 1 is 1, like yes, this one survives. If they reply to somebody else, we kick it all out. What's nice though is we can also do some interesting shorthand. So now we can compose 2 different things here. Keywords act as functions on maps. Earlier in that example, I showed like, oh, we've got this map, A is 1, B is whatever, and I basically went like, to get the value out was :A in my map. And we got a value out. That's as if we applied a function to the map. It can work that way. It's a beautiful little shorthand. So in this case, the first tweet comes in, and we say we're going to apply the function in reply to user ID string on you, and we're going to get a value out. Then the second one, so now like the guy said, like we work it from right to left. The second thing is we're going to now take that value, sets. This is shorthand for creating a set when you use hash and the curly braces around something. Sets are functions of themselves or of their members. So now you can basically go, I've got a set of 1, 2, 3, is 1 in here, and it will return 1. Is 4 in here, it will return 0. So from these 2 things, you can compose like a super short, concise way of filtering through data. And this becomes like a really nice way to express filtering problems. And this becomes the kind of thing that you can give users like toggles in UIs, and they can start building out the predicates that you compose for filtering like a massive amount of data. In this case, it's nice and simple and small. And this scales out, which is absolutely fantastic. And this whole thing gives us a new function. It's a pity my REPL's dead. Oh. I'll see if I can get it connected. I'll show you how it works. Anyway, okay. So what did we do here? So at this stage, when our assemble threads got called, we had one huge list of all our tweets, including our starting point. We made a short list, which at this stage is basically they just order it by date, and it's only the person replying to themselves. We've got no guarantee yet that it's actually part of our tweet storm that we're unrolling. And then, like one of my favorite functions and one of the most powerful functions, I guess, in functional programming, period, is reduce. Who's played with reduce in any way, shape, or form in any language? Yeah, okay, cool, that's great. Like, that's, like, sweet. So basically, we end up, our first arguments are reducing function. We need to start out our accumulator with something. So we just want to say, like, I'm going to start with our starting tweet, and then we give it the short list. Now, our reducing function basically, in this case, gets called with, this is our thread. So the first time it gets called, it's only our starting tweet. And that tweet, in this case, is actually the starting tweet as well. So the first one's a no-op. It'll just run through. But if you think now the second iteration on here is we will be able to look back at our accumulated thread and we go like, I just want the last one. And I just want to check if this new one I got is in reply to that one. And we're hoping it's kind of true. Like this is very wishful thinking that our earlier sorting like got the whole chronology right. Because if something's out of whack, we'll miss it and our thread will be broken. So very optimistic thinking. And then basically like it boils down to if our previous ID matches our in reply to on the current one, we just want to conjoin it on the thread. So basically append it to our thread list. Otherwise, we just give our thread back. Should have mentioned earlier, Clojure has that implicit returns. So that explicit return inside the debugging functions, all of that's gone. The last value is always the one that propagates up. And in an if statement, in this case, thread will just pop out. It becomes our new accumulator, and we go through every one in the list. This morning I had like a loop that wouldn't have fitted on the screen, and it was quite nice to actually tear the problem apart a bit and break it down into a ton of functions and be, there we go. So that's kind of a sorting problem. This one I was also quite happy with. It turned out quite neat with the interrupt. So basically, so now we've got our thread, but Twitter truncated our values. So that basically means now we need to go make an API call for every single tweet because we want the full text. That's essentially what we want. So this becomes a very, very simple map function with an anonymous map function. And they do provide this property whether the tweet's been truncated, yes or no. So basically go, if it has been truncated, so this would return true, like go get me the full tweet. Otherwise, just resolve a promise immediately with whatever we've got. There's no need to go out over the network. And then all of this gets piped to promise.all that we all know. So now that will like neatly do its thing and give us a new one out. And then that's basically the expanding part. And then we finally terminate the promise with the print head. And yeah, I also went a bit bonkers again with just showing off the interrupt. Who's used chalk to do like colorized output in Node scripts in the terminals and stuff? Yeah, so that's like most of your tools that when they do nice colors and it ends up being chalk underneath. So I was like, well, let's play with it a bit. So we create like a little separator so that we can distinguish between our tweets. And then the same thing here. Now we're just going to do this list processing. We just start off with a bunch of tweets. And the first thing we're going to do is we want to turn them into something printable, which in this case is just a simple string of the full text, a new line, a dash, and the date. And the date kind of helps us to see if the chronology is right. And again, the interrupt. So chalk got required out of NPM directly. And we're just calling the blue function on it and passing the raw datetime object in as its argument. And chalk does its work. And returns us, well, I assume a string or something. It's got like the ASCII encoding that the terminal wants. We interpose a separator, just so we've got like a nice line between everything. And we join it all with a new line, and we send it off to console.log. And we are done. What that ends up, oh, I changed networks.
I can't see anything.
Yeah, I'm going to zoom in now. This is not exciting. This is just a build tool.
It's so exciting.
But that's basically, it's just running through yarn. Yarn shadow CLJS. So this side, there's our spoiler up there, damn it. There it basically gave us exactly what we wanted. But I knew. There's an unrolled tweet storm. But what's important here is what you're seeing here on the terminal is a Node process connected to a separate like Java process that's busy driving out all the stuff, although we started it out with yarn. And then in our REPL, so this thing should have died now, but let's just kill it properly. Proto REPL. Okay, connect, localhost that, done. Okay, sorry, I've got a little dance here that I'm still figuring out. Basically, this is like something you would do the first time you.
What's going on?
This is stuff I needed to. Oh, it's not connected. I wanted to show this. Okay. The networking is iffy. This thing doesn't want to connect. It's actually something I've battled with the tool. If you switch networks a lot, like I kind of do, you need to tear down your whole environment and bring it up. I'm going to help report an issue. But here, when I could get the REPL to connect properly and do the work, as you're busy working with the functions and changing code and saving, the compiler will be constantly updating the code. So if we look, I'm going to select this line so we know we kind of, that's where we were. And now we just come and make some changes. There in an instant, it recompiled our new version, and we can keep on working with it. What you can also do in this case actually is, I set it up so that these two functions get called as it like reloads the code. So you can just kind of get some feedback, and we should have seen starting in the output here. Where is it? No. It should be here. Whoa! I need power. That's all happening. Too much. Yeah, that's kind of that part. Sorry, but I feel like I'm dragging on. I just want to show you one last thing. In this case, I basically compiled out a different compile target, and this gave us like a bunch of optimized JavaScript that can now be copied and run somewhere else. Where the other build, the separate build we've got with the dev tooling, is quite useless on its own. There's nothing it can do. But it's specifically there for going through the development loop, where this one now becomes a piece of JavaScript that looks something like this. Absolute crazy mess. But my background color is, where's the Vim people? Set
BG space.
Is that better? Yeah. So this is the kind of boring JavaScript that Clojure spits out for us. But there's everything with proper Node stuff in between. It's quite a beast this way. Okay, I'm going to try this. I haven't. So you guys another example. Let's see if we can get an advanced compile. No, I need to configure it. I'm not going to do it. If you use the advanced compilation mode in the Google Clojure compiler, so the Google Clojure compiler is a key underpinning of how ClojureScript works, and this thing is absolutely amazing. I feel like Google has spent so much work in this compiler building something that powers all the web properties. Like tree shaking is now becoming a big thing in the Webpack world, and people are trying to solve this problem, and it's a hard problem. I mean, I take my hat off to anybody who are like, I wouldn't want to tackle that. But it's been in the Google Clojure compiler for like a decade. Why are we not using any of that stuff? The advanced optimizations and stuff you get is absolutely bonkers. And with a Node script, it doesn't make any sense to do that. But if you start shipping big bundles to a browser, that makes a hell of a difference. And the way this tooling can start walking up the chain gives you something super powerful, especially if you start thinking, well, I've got Clojure as a whole language that I need to ship with. Like, if you just think about it, that can become super heavy. But now the way the Clojure compiler reaches into all your code, it will only pull out the Clojure functions or the JavaScript versions of the set functions as you need it. It's got facilities for hot code migration, which I think is something that the Webpack world hasn't really, I'm struggling still to wrap my head around it. But you can tell it like, I've got a namespace in my code that's shared between all my different artifacts that I'm building, and please put that in a separate library for me. And it will literally rewrite all your code to start requiring that piece. So you can think of creating like a vendor bundle that's got all your like extra stuff, that stuff that infrequently changes in your project. If you now ship that with a proper fingerprinted file with far future expiry headers, you get like something really, really sweet.
And it will write the like module loading code.
Yeah, all of that. You just include.
You don't even notice if you just make a function call. And it goes, oh, I don't actually have that. Then they go fetch it. Next time, oh no, I've got it. It's all transparent. It's kind of
Yeah. So it's an amazing tool chain to build on top of. But I need to be respectful of your time. It's just all over the place. So shadowcljs.org, the guys actually got great docs. There's a few holes in there. I made a lot of notes. I think I'm going to try and help there. ClojureScript.org also recently with the 1.10 release of ClojureScript, they like redid the whole quick start guide, and it's slick now. These people have really put a lot of thought in it, and I would recommend that really as a way of exploring this world. Like I said, rewriting a backend's never going to happen. It works with any editor you can think of. Emacs, if you know it, the best way to get going. If you don't, park Emacs for next year. Like, get used to your own tools. It's too big a shift. But there's Cursor for IntelliJ. You saw it work, well, mostly work in Atom now. It worked earlier, I promise you. VS Code's got plugins. There's even a bunch of stuff for Vim. I used to be a Vim user, but I think there's like a mismatch between Vim's modal editing and this kind of rich experience where all the other ones are right. So there might be a bit of friction. I don't think it'll be as smooth, but it works and people use it and they love that tool and they get stuff done, which is the most important way. And that's my story. Thank you.
the rapture of Clojure.
That was a bit all over the place. Any questions?
So to point out, you were talking about Clojure, Google Clojure project earlier, right?
CLOSURE.
Yeah.
So the interesting thing, Angular.
Mm.
They, as a part of their CLI, ship Webpack.
Yeah.
So when you build your stuff, you use Webpack to do the tree shaking, etc., etc. But when they build Angular, they use Bazel and Clojure.
Okay.
They don't use Webpack.
Yeah.
They can't get it small enough.
Some of the Clojure guys repackaged React as released by Facebook, the production build, with Google Clojure, and they still shave like 20% or something off the payload, just dead functions. There's something I didn't show you because the Node with it doesn't work, but I thought about it. You guys said like putting the debugging functions in your pipelines and stuff. One of the amazing things with Clojure, with Google Clojure and then ClojureScript working together is you can literally the compiler can figure out when you've got dead code paths. So when you're building those chains of functions, you can have debug functions in between that depend on some kind of Boolean flag, but not like a normal code, like a compiler kind of flag. And when you do a production build, you set that to false, and the compiler knows it's got to elide the code properly, like it just disappears out the code base. So it's never even like remembering the one console.log that you have to disable. The code is not shipped. And there's a lot of Clojure libraries that depend on that. Like there's some profiling tools, so you profile in development, but you never profile in production. The profiling code isn't even shipped. If you use trace and debug log statements, you can tell the compiler like, look, I'm never going to switch my app into those low levels of debugging in prod ever, so just strip it all out the system. And it doesn't even ship. Like it's.
There's a super nice demo on the Google Clojure site where they take like a big chunk of JavaScript, it's got like some functions, some of the functions don't get called, and then you run it through the like normal one and get this. Then you run it through the advanced and you get A equals 2. And it's just crazy. Like, hang on, it like, figured out a function was only getting called once, and it always returned 2. So there's like no point in all that code. Just all that's left is A. Like, what?
Yeah.
All my hard work.
But as with all functional stuff, like I would recommend go play with it. This is something I wish everybody would take this into production. Life's a lot simpler. That said, there's still something hugely valuable in playing with something as different as this. I believe it's a good different, but it's still like something that shakes you a bit. It makes you like look at code differently. It makes you think about the dangers of mutation, like all the stuff. Like Clojure is dynamic and immutable. Like nothing I had there could change. Like whenever you saw a value there, that value it had was the last value it ever had. You can't go and like fiddle and do stuff. It's got very explicit like types for when you need mutation. And it's safe. It's like an escape hatch, and you know you need something now, and for the rest you just go. It's a really rewarding journey. And this is nice because it's dynamically typed, so it fits really well into the JavaScript world. It's also strict typing, so you can't go from a string to an int depending on the context. When it's that, end of story. But you don't have to mission with all these other things. It's a great play in the ecosystem. So you can cut out like a piece of a system and like replace one of your Node modules with a ClojureScript module and just see how it behaves, if you like it. And if not, you just delete it. Like there's no real thing spent, but there's something that comes out of it that's like enriches you. And that I think that's like, I push, try that. And we're in ZA Tech in Slack. We're all in the Clojure channel always. So if you've got any questions, you can more hit us up there as well. And we'll be hanging around for a bit as well. So thanks. Thank you.